Run hello world on multithread. Here is the source code to print out hello world in multithread. At the line #pragma OMP parallel, multiple threads are spawned to create parallel regions and print out hello world concurrently. OpenMP function OMP_getThreadNum is used inside the parallel region. It displays the thread ID. And the output looks like this. Important thing here is that the threads are not executed in order by default. You might have expected from thread 0, 1, 2, then 3, but that's not the case. Also, I did not specify the number of thread to use, but OpenMP automatically used the number of cores available on my machine by default, in this case 4 cores. You can also dynamically set the number of thread you use. There's an OpenMP function to do it called OMP set num thread. Since this is a command inside your source code, you need to recompile the code when you make a change. Another way to set the number of thread is by using an environment variable OpenNumThreads. The command export sets OMP num thread as an environment variable. Another thing to mention here is that the operating system maps the thread to available hardware. You do not normally want to exceed the number of core processors available to you. There are some useful commands to check the parallelism of the code. The command top or htop looks into a process. As you can see from the image on right, it shows CPU usages, and you can check if all the CPUs are utilized in your code. There is also a command called time to check the overall performance of your code. By running this command time, you get real time, user time, and system time displayed. Real time is wall clock time. It's the time from start to finish of the call. This includes the time of overhead. User time is the amount of CPU time spent outside the kernel within the process. Similarly, system time is the amount of CPU time spent in the kernel within the process. So basically, user time plus system time will tell you how much actual CPU time your process used.